In problem 4.43 and carrier frequency omega c is omega c of 1005. Use equation 4.20 to determine the time domain expression for phi LSB in the time domain and also phi USB in the time domain. Hint: if m of t is sinusoid, it's Hilbert transform. mh of t is the sinusoid, m of t phase delayed by 5/2 radians. Okay, here the two message signal provided, and we have to find out what is the phi of the time domain expression for the low side band and upper side band. Okay, both of them should be in the time domain. Now let's look at the given equation. Let's do the A part. In the A part, we have m of t is equal to cos 100 phi t, cos 100 phi t plus 2 cos 300 phi t. And as it mentioned, equation 420, that is containing these three equations. And here you can see the time domain expression for the upper side band is given by m of t cos omega ct minus mh of t sin omega ct. Okay, that's time domain. And in order to express this one, we had to find out what is this Hilbert transform, that is mh of t. We have m of t available readily, so this is not a problem. This one is already we have, but to express this one, we need to find out what is this one is. Then we can put it in this equation and express it. That's going to be the end. Now to find out the Hilbert transform, that is mh of t, what we have to do is, as it mentioned here, it's always like that, like it's always shift of 90 degree. That's 5/2 radians. So if you shift the frequency of this m of t by 90 degree, then you're going to get the Hilbert transform. Okay, now let's go ahead and do that. Actually, angular frequency omega, we are shifting omega. So here cos 100 phi t shifted by 5/2 and then plus 2 cos 300 phi t shifted by 5/2. Okay, it's negative 90 degree shift always. Okay, we can also mention that here Hilbert transform in time domain is phase shift or delayed by minus 90 degree. That is expressed as 5/2 here. Okay, now if you shift cos wave by 90 degree, if you subtract 90 degree from it, that will become a sine. So this become a sine 100 phi t. If you shift cos 100 phi t by 5/2, that is equivalent to sine 100 phi t. And then same thing apply here as well. So this is plus 2 sine 300 phi t. Okay, now we have expression for the mh of t. Now we can go ahead and apply in the first equation to express the USB in the time domain. That is phi of USB is given by upper side band, that's given by m of t cos omega ct minus mh of t sin omega ct. m of t, we know that cos 100 phi t plus 300 phi t, so let's put that one right here. Cos 100 phi t plus 2 cos 300 phi t okay, that one multiplied by cos omega ct, that is cos omega c is given in the question, that is 1000 phi, so we can substitute that one here. So 1000 phi t, and then minus mh of t, that is sin 100 phi t and then plus 2 sin 300 phi t sin 300 phi t, and then that one multiplied by cos 1000 phi t again, because in the actually sin 1000 phi t, because sin omega ct, so this is going to be sin 1000 phi t. Okay, and if you look at the difference between USB and LSB, only the sign. Here we put a minus sign here. Okay, this is equal and this is continuous, and I put it down here because of no space, but this is minus right here. But for the LSB, that's plus. Other than that, everything is going to be same. So if we express this one for phi LSB, the equation is given by m of t cos omega ct, m of t cos omega ct, and then in this case this is plus, and then mh of t sin omega ct, mh of t sin omega ct, m of t again is exact same thing. So even if I just copy this one and paste it here, it's gonna be the same. So it's the same thing. The only difference is this minus now turn into plus. Okay, and I should have just write continuously here. So let's write this one continuously. Let's see if I can. Okay, so right now it looks perfect, and this part I can just remove it. Okay, and this is a plus sign here. Okay, this is m of t. You look at this one, this is m of t cos omega ct, this one is mh of t, and this one is for sin omega ct. Okay, and that is the lower side band. Now we have to do the same thing for the part B. Let's write the equation somewhere. I'm going to create a new page for it. So the next message signal provided to us, we are doing the part B, that is given by sin 100 phi t sin 500 phi t, sin 100 phi t sin 500 phi t. Now in order to apply the Hilbert transform, it's better to try, express this one in cos addition. So to do that, if you know the one of the property that when we have two sign multiplies, there's a property that says it's half of the value of half of the amplitude. So this is amplitude 1, so this is going to be half, and that one multiply by cos a plus b minus cos A minus B. A is the value that has higher frequency, higher omega value. So here in this case 505 is the higher omega, so this is gonna act as a A. Okay, now let's go ahead and substitute that. So this is going to be half time cos A plus B, but A minus B comes first, so this is cos A minus B, that is 500 minus 100, 5t, 500 5t minus 100. So we are just subtracting omega t values. So 500 5t minus 100 5t, and then the half is common for both of them. The next expression I'm going to bring as well. So and then there's a subtraction sign, and then cos 500 5t plus 100 5t. Okay, and that's the expression. And if you simplify this one, this is going to be half cos 400 5t minus cos 600 5t. And finally we can multiply both of them by half as well. So this is going to be half time cos 400 5t and half time cos 600 5t, and this is m of t. Okay, now in order to express the upper side band and lower side band, we need the Hilbert transform as well. So we can just write the Hilbert transform of this one, mh of t, that is just the 90 degree minus 90 degree shift. So if you put minus 90 degree minus 5 by 2 to for the omega ct right here, that's going to turn into sine. So this is going to be half cos actually sine. So it's going to be same values with the sine. So this is half sine 400 5t and then minus half sine 600 5t. Okay, now we have m of t, mh of t, and cos omega ct. We know the omega c is 1005, so we have all the values to express phi usb and phi lsb in time domain. So let's express the phi usb first. Phi usb is given by m of t cos omega ct minus mh of t sin omega ct. Phi usb is given by m of t cos omega ct minus mh of t, that's Hilbert transform, mh of t multiplied by sin omega ct, and we have the values here. Let's use a different graph. So m of t, that is half cos 400 5t and then minus half cos 600 5t, that one multiplied by cos omega ct. Omega c is given in the question, that is 1005. So this is going to be this one multiplied by cos 1005t and then minus. Now I'm going to have a problem, that is I cannot continue here because I don't have space. I'm going to copy this one and bring it to the next page. Okay, let's create a new page and put it here. Okay, so this is the expression we have, and I'm going to put the minus in the bottom and continue here. So minus, and then mh of t is same expression with sine. So this is half sine 400 5t minus half sine 600 5t multiplied by sine omega ct, that is sine 105, sine 1000 5t. Okay, so that is USB, and LSB is exact same thing with a plus sign. Okay, we just have to put a plus for it. So if you just copy this one and change minus into plus, that's the LSB. So here this is LSB. For this one, the minus turns into plus, and this minus turns into plus, and that's it. That's our LSB expression in time domain. And you can also mention time domain here as well of t. And here also for this one we can just mention this is expressed in time domain. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.